In this lesson, we're going to learn how to create our own little process and send it to the background. Then we're going to use the kill command in order to stop the process by sending it a sig stop signal and then start the process again. So in order to do this, we're going to write just a real simple script on our command line. I'm going to do while true. It's saying while true basically until we tell it otherwise, because we're going to stop and start this with kill signals. Do, and then the command we're going to do is we're going to echo suppress any line breaks, and then my program. This program is going to output or append to our home directory inside of the output.file. And then we are done. And so basically it's going to continuously do this over and over and over and over and over again. So we could specify, hey, we want to sleep and give it 1 second, or take 1 second before you do this again. We're actually going to use a similar version of this to increase our CPU processor speed and some later examples. So if I do this, we see that our job, because I pass it this and symbol means take whatever we type at the command line and send it to the background. So if I do a jobs command, I can see what processes are running in the background of my current terminal session. So I've started this. Let's say I want to stop this now. I don't want to terminate it. I just want to stop it. This is a prime example of really kind of viewing signals in terms of terminating and stopping. I can do that by saying kill. Now remember, if I don't pass it anything, my default is going to be 15 or sig term. Instead, what I want to do is I want to send it a sig stop. And then we do sig stop. And then I want to specify my job number. I have one job running, so my current job number is 1. If I had 2, I would have 1 and 2 for job numbers. So to specify the job number, I do need to put in the % and then my job number, which will be 1. So if I do this and I hit enter, then I type jobs again, we see the status of my process. We've actually stopped this job. We've stopped the process from executing. Okay, well, I'm ready to continue, so I'm going to do a kill sig continue and then my job number. And then if I do jobs again, we see that the process is now running again. So I can start and stop processes using the kill signals. So that's really cool. Let's go ahead and pass it a sig term. So I'm not going to do any flags here because we'll just keep it default. And I'll do kill %1, which represents this job running in the background of our program here. That's what our %1 does. And then we'll go ahead and hit enter. We'll type jobs, and we see that the process has been terminated. We'll do an ls on the home directory, and we can see that there's our output.file that has been created. Now that we've done this, we've learned how to start and stop programs using kill signals. That's very, very cool for us. Now I'm going to go ahead and do a systemctl start on my HTTPD service. That way, if I do a pgrep and then search for HTTPD, I see that I have services running. Well, let's go ahead and look a little bit at our ps command. If I type ps, immediately what I'm going to get is I'm going to get processes owned by this user, or started by this user for this terminal session. You see we currently don't have anything. We have the ps command, our bash terminal, and we've su'd into the root user from the user instead of logging directly in to the system as root. Now there's multiple different ways to use the ps command. We have POSIX type flags. We have what's called Unix similar flags, because the ps command is actually a really, really old tool. So if I do a man ps, what I see here is I see different ways of doing it. We have BSD syntax. You notice there's no dash. We can print process tree. So there's really cool and many different ways of using this. So let's just take a look real quick at one of them we're going to do. We're going to use a PSAXO. And like I said, there's many different ways of using this. When we don't do it with the dash, it's going to be BSD style syntax. So we look at A and it says list the BSD style only your self-restriction, which is imposed upon the set of all processes. Options are used when the PS personality setting is BSD-like. As you can see in the style here, we have the X, which says with all processes, when used with the -A option, list all processes. So we can list all processes on the system. We're actually going to use the A, which when used with the X option will list all processes. And then we're also going to use the U option. So let's go take a look at what the U option is. The U option will display user-oriented format. So if I did a PSAUX, what it's going to do is it's basically going to give us a dump of all processes running on our system. What I could do is I could pipe this into the grep program and then grep for HTTPD. You'll notice that we have HTTPD processes running on our system. It shows what user owns it. We have root, Apache, and again root. It says our process ID. This here is going to be our process ID. And it's going to say what command started the process, what command started this program, or again, the process. When used with kill, I can kill a specific process ID. So let's say I wanted to kill this process 2373. I would do a kill 2373, and again, because I'm not passing it a signal, it's going to use 15. And if we were to go back up and grep again, we would see that that process no longer exists. So that's how we could kill individual process IDs. If we had the process ID, I could do a kill. I could also send it a -9 to kill quickly without potential hangup, 2374, and it'll kill that process or that specific process. Now, if you notice, what's happening is we have a program that's automatically launching a new process for the HTTPD. So we're not killing the right processes. That's really what pkill comes in handy for. So we can do a pkill HTTPD. And if we come back, we see that it no longer is running. So the program that launches the HTTP programs, that process is no longer here. Now, pgrep is going to be more for us to use. I would encourage you to read the manual on PS. Generally, I like to use it with just PSAUX. Now, there's different ways of doing it. We can use the PS command and view information like a nice level. So what is the nice level? The nice level is a niceness of a process, which means kind of the priority. So with a lower nice level, that means the process is going to get more priority to CPU utilization than processes with a higher nice level. So an example of this, and if I want to do a man PS again, we're going to do a PSAXO. Now, the PSAXO option, let's just go ahead and take a look at what it is. We're going to see every process with a user-defined format, right? So we have AXO, and then we have these really kind of process information that we're going to pull from it. So if I do an example, PSAXO, I want the PID, I want the command that caused it to run, COM, and then I want the nice level of it. And so this is what we have. We have the PID, the command, and the nice level. And we're going to get into the nice in the next lesson. I'm just kind of showing you how we can view the nice level of specific currently running processes on a system. Now, the other thing I want to show you is we have those headers that we can choose from. So if I were to come down here, I see, if I browse up a little bit, I see that I have nice. I can pull the process ID. I can pull the user. I can pull the command, the arguments passed to it, the time that it was launched. So these are my options or my header options to pull. So that's where I came up with this PID, COM, and nice. And again, for AXO, if we take a look at our PS and we come down here, it shows us our AXO in our example. If I look in example, I see AXO, and this is also how I would get those. Now, if I wanted, I could do a ps-u root, and I can look for all processes owned by the root user. So that's what the -u does. So when we're using POSIX or Linux type flags with the dash versus BSD style flags, we get different behavior from our process or our PS command. And if you want to, if you're worried that the behaviors are working differently, generally it's because you're using a little bit different. So that's how we use our PS command. That's how we view what processes are running, and that's how we could kill specific processes on it. Now, if I wanted to, I could log back into my linuxacademy.com lab server. Inside of here, if I did a W, we would see that we have PTS1 for my Linux user. If I did a ps-aux, which is going to list all process IDs on a system, and I grep for that PTS0, what I'm going to get is I'm going to get a process ID for that specific user. Now, my concern here is that it's the root user. If you notice, I used 0 instead of 1. So if I do my 1, it's going to give me my PS ID for that user. And so what I can do is I can actually boot that user now. I could do a kill, and I'm going to pass it a -9. So kill without attempting to do any type of cleanup or exit cleanly. I can do 2509 there, and it's going to kill my user's terminal session. If I come back over, we notice that we've been closed off from the connection. So that's again how we can use the kill command on a PS command. Now, in our next lesson, what we're going to do is we're going to learn about the niceness, setting the niceness, launching niceness, and renicing programs. So that concludes it for this lesson. Go ahead and complete this lesson and move on.